fix some problems. It's COMP228 Java programming, and it's lesson 13, part 2, where we're talking about multi-threading. And let's get right into this Eclipse stuff really quickly. So I'm going to go into, like I said before, Eclipse, and I'm using Eclipse Mars for those people out there, right? It's all because of Avneet. It's all her fault, right? Because of her, I'm using Mars because of you, right? Let's set up a new project. So we're going to say a new Java project, right? Which we're going to call, of course, COMP228 lesson 13, right? And we're going to say finish, right? I'm also going to, of course, make this into a repository. So I'm going to go into, I need to do that. So in lesson 13, I'll use the in-house tools by going to share project and create. I'm going to point to where I'm going to create this. I'm going to go down to courses and where I have my files. You are going to have your files in different places. So this is lesson 13 here, and press open, press finish. It's going to give me an error, which I'm going to ignore, but it's going to give me this, no head kind of thing right here. And what I'm going to do here is I'm going to go into team, and I'm also going to go into commit, and we're going to say initial commit. I don't have anything in there right now, just a couple of things. Just commit. I'm going to select all of these, so select all, right? And I'm going to commit and push, and it's going to ask me for a place to push it to, which I don't have yet. So I'm going to go up online. I'm going to go to GitHub, and on GitHub, I'm going to create a new repository for Centennial College, which we're going to call COMP228 lesson 13. And I'm going to get my URI information right here, which this is the information I need. So copy this, go back into Eclipse, and where it says URI, paste. It's going to fill all the other information in, and when I click next, and finish, it's going to publish everything up onto GitHub. So we're ready to go. Okay, so our repository has been created. We've got our blank application space. Let's make this thing go. So first of all, let's create a new class. We're going to make a new driver class, right? So a new class, which we're going to call main this time, or program. Let's all call program. Our program class. And we're going to make our main, public static void main. We're going to kill the other constructors and inherited abstract methods. And from a package perspective, since we've learned about packages also as an ancillary technology we're learning about, we're going to do reverse domain namespacing. Hint, hint, it will be on your exam. The domain name that we're going to use, which is going to be, let's say Centennial College. And we're going to call this thing a lesson or lesson 13, whatever. And we can make the whole application name if you want. You can go something like comp, or lowercase, COMP228, right? Lesson 13, no spaces, or a dash. Notice how it says dash is not valid, right? So you have to use underscore, COMP228, right? And then it's lesson 13, right? So that's my new package, right? Press finish. And what you're going to do is going to create my thing that we're used to, but this is our custom package is com.centennialcollege.com228 lesson 13, right? That's our package, right? And now I need so this is our driver class. That's what this thing is. So this is our driver class. That's all it's for. And what we also need to add in is another class. Let's make another class. We'll do an example of a thread that's going to inherit. Remember we talked about inheritance, right? So here we're going to create a new name. We're going to call this thread our new class, my thread. That's our class, right? It's my new thread, right? And instead of having the superclass of Java lang object, we're going to inherit. We're going to click browse, and I'm going to put in there thread, right? And notice how thread comes from java.lang, right? So I'm going to click that, press OK. So you should have in the superclass section java.lang.thread. I'm not going to click anything else in here. Don't click public static or constructors from superclass or anything else. All right, and press finish. Now it creates this little thread, and if you notice, it's still part of the same package, which is good, right? And it extends thread. Well, what I want to do really quickly is if I right-click and if I go to source, right? So if I go to where you find source, if I go to override implement methods, I'm waiting for you guys to catch up. Override implement methods. If I click onto that, it'll give me a bunch of stuff in here. One of them that I really want to override or implement is this thing called run. See this thing, run? Click on that and press OK. All right, notice how I have my little run method. I don't care about this stuff, right? But I have my little run method. In here is the thread. Is because my class extends thread. Anything that I have in my run method is the thing, a bunch of instructions I'm going to run. All right, this is where I'm going to execute. When I run my thread, I'm going to execute the stuff that's in my run method, or the stuff that my run method is pointing to. If I have multiple methods and my run method is pointing to other methods, those methods will run. Here's what I don't need. Do I really need my superclass run? Chances are not. So if I get rid of it, I could. Let's leave it in place for now, and we'll talk about getting it out of there and see what the difference is. If I go in here and I want to make some kind of for loop, this is a classic example, right? So for, and I go int I index, let's say, is equal to 0, where index is less than 100, running 100 times. Let's make it 10 times so we can see it. 10, and then we're index at the end plus plus. We're implementing index at the end. And here in this example here, we're going to do some kind of print statement, right, to console. So we're going to sys out, and we're going to control space, and we're going to say in our console, we're going to say something like, you know, thread count, right, plus I index. Okay, cool. So all this little thing will do is run a for loop, right? Right? And what we're going to do, right, is between threads, between the loops, right, we're going to use the sleep methods. We're going to say sleep, right? And we're going to sleep, as an example, I don't know, 1,000 milliseconds. Okay. Now, notice how it says, hey, there's a problem with this. I don't understand what this is. It says, I have a problem. It says, surround with try catch because it's an unhandled exception of type interrupted exception. Right? So let's do that. So surround with a try catch. And, you know, we're going to have a sysair, control space. We're going to kind of put in there, you know, thread interrupted. We're going to put in there, right? And we'll say in plus E exception. Actually, I don't like E. Let's rename this exception because I think E is cheese exception. Whenever I see E, it's like, meh, hate it. Okay, cool. So that's just the little task that we've made. We've made this little task that runs. Here's the run, the thing that we're going to run. And all we're doing is in the run, we have this little for loop. This is our task. Okay, so we're going to run this task. Okay, now I need to, once I've got this, you guys all good with this one? So all I'm doing is inheriting. Remember we talked about inheritance, bad? Inheriting from thread, the thread class. And then when we inherit from the thread class, we're going to run this little task every time the run method is called. Well, guess what? The run method is called, right? As soon as I click on whatever my thread is called, and I use the start, I have to use the start method to actually run the run method. We'll talk about that. This is a thread. Threads have the start method, and they also have a stop kind of thing, right? So let's go back to my program.java now. after I've got, if do you guys need to see this more? Are you still good, or did you copy this in yet? By the way, guys, this is not a complex little algorithm, right? This is nothing, right? Sleep is interesting. So what sleep does is it makes you wait. So wait for 1,000 milliseconds. 1,000 milliseconds is actually equal to 1 second. That's what it is, right? That's what it is. So before, in between loops, it's going to wait 1,000 milliseconds. So it's going to take 10 seconds to run this for loop. Right? So it's going to run, and every time it's going to wait before it increments or it iterates, it's going to wait a second. We can change this, by the way, right? Hey, if you were going to make a game loop, you'd make a while loop instead of a for loop. That would be an unbreakable while, endless loop, right? Game loop. And instead of iterating every second, right? How often would you iterate? every 16 milliseconds, I think, or something like that, right? Because 16 milliseconds times 60, I think, is 1,000. And I'm guessing. I think it's 16. I'm not sure what it is. Is it 16? Aaron? He's not checking. Okay, let's go on. So that we've done this, I'm gonna save my file. I'm gonna go back to my program, and in here, my program, this is my main driver class. I need to declare it as a member, right? So I have to kind of declare it as an option, as an object, right? So I'm gonna say my thread. We'll just call this, thread is equal to new. We're going to use the empty constructor because we don't need anything else. The default constructor, my thread. Right? We're not going to send anything to my thread, right? That's legal. And in order for us to start the thread, we just have to do thread dot start, right? And when we do thread dot start, it's going to start off this method, right? So if I just do that, right? So I got nothing else in my main. So here in my main, because this is my driver class, I'm actually in my main process, my main thread right here. My main thread is running actually, but there's nothing that's running in my main thread, just this, which I'm calling a secondary thread. So my secondary thread is this thing called thread, right? And if I run this thing just by the way it is, I should get a thread count that happens every second. Take a look. So it waits 1,000 milliseconds, like a countdown, and it counts 1, 2, 3, 4, 5, 6, 7, 8, 9 because it starts with 0, right? I went to 0 to 9. So that ran, and all I did for that was call a for loop that ran here. That's nice, but that looks like just like a for loop. Well, let's run something in the meantime. So in my main program, we'll run another for loop. So we'll say for, and we'll call this index as well. Int index, classic example, guys, is equal to 0. Index is less than 10. And then index plus plus, same thing as we did before. And this time, we'll do the same exact thing. We'll just copy the line we have in here. And we'll also sleep 1,000, okay? But we'll grab all this stuff that's inside the middle, copy it, and go over here and paste it, right? And now, how come we can't run sleep 1,000 up here? There's a reason for it. Well, because it's not a thread. This main class isn't a thread. The reason why we can run it here is because sleep is part of the thread class, right? So because sleep is part of the thread class, is a method of the thread class, and we're inheriting from thread, we can run sleep without anything in front of it, right? Whereas here, right, there is no sleep, so we have to actually run the superclass thread.sleep, if I'm not wrong, right? And that we can run it here outside of our program, right? Now here's something. Instead of our thread count, we're going to have this. We're going to call this main count. So we know this is our main thread, if you will, right? We're still going to count to 10. We're still going to wait 1,000, and we're going to run it after we start our secondary thread. Okay, let's see what this does now. So here we're going to start our main thread. So start our main operation, whatever the operation is. Right, we're just making a for loop. Who cares? But we have a thread that's starting already in the background. So this is start our secondary thread. Start secondary thread. We can do this by any time. We'll try moving this around and see what it does. Okay, so and I run this thing. So let's see what happens. So here's main count 0. Take a look. Thread count 0, thread count 1, main count 1, thread count 2, main count 2, thread count 3, main count 3, main count 4, thread count 4, thread count 5. That's what's happening. This is not what normally happens in an application, right? Our application only does one loop at a time, right? It's not what's happening here. What's happening is it's interleaving, that's the term I want you to remember, between the two. So it's actually, you're running two different tasks at the same time, right? So what's happening is it goes from thread start. Notice how it starts even though I started my thread start first, it started with my main count first. Why? My main count, my main thread takes priority over the other threads. The other thread, right, which is my secondary thread, it counted twice, 0 and 1, and then our main count said fired off 1, right? So it kind of interleaves as best as possible different threads. Cool. That's our thread start. Let's make this something else. Let's just from as a lark, let's make a couple of them. So I'll say thread 1. We'll call this thread 1, right? And we'll say thread 1.start, right? And you know what? We'll make another one called thread 2. So we'll say, my thread Actually, we'll copy the whole line and just call thread 2. And we'll copy these 2 lines here. So copy those 2 lines and go down here and paste. And this time we'll just change the numbers to from thread 1 to thread 2. Thread 2, because I'm really lazy, and I'll move this one up. So we declare it first. This is our thread. We declare a class, an object, a couple objects. I'm just going to get rid of all this. And now we have a couple of threads here. We're starting, right? Now they're going to say the same thing, thread counts, as an example, right? And you know what? Just to make it interesting, right? When I make the thread, right? In my thread, I'm going to make a make my own constructor, which is how to make a constructor for a thread. My thread, right? And on my thread, I want to look for the name of my thread, which is a string, right? So string name, right? And what I want to do in my name is it return anything? No, it's void, right? And it has to be public, right? Because it's a constructor. So if I put public in there, can I put public in there if it's a constructor? Yes, I can, right? And let's make a private instance variable. So here's our private instance variables, or member, if you will, right? We're going to call this name, right? So we're going to make a string private string underscore name, and we're going to say this dot underscore name is equal to name. Yes.
Yeah,
I'm saying. It's not giving me an issue. Right? I don't need it. Don't need it, but that's what I'm saying. I was saying public I could have there. But could I have, do I need public? If I don't put public in there, is that a problem? No, right? Because public, by default, constructors are public, right? So my thread, string name, this name, right? And what I could say instead of whatever the string name is, I could say thread, and we'll say plus, modify this line, system error, oh, wait, not this, here. Thread, I'll be okay. Thread with a space, plus, and then this dot name, the name of the thread, right? Plus my count, you know, whatever the count is, right? So this name, so it's going to show us the name of the thread. Makes sense? I'm modifying it so we can see the name of the thread. So it's going to ask for a name now. One of the constructors, it's going to ask for a name, and now the default constructor is it still there?
No.
Because if I go back to my program Java, look what's happening. I'm getting this error, right? Because once I program a custom constructor, unless I program manually, unless I physically code my empty constructor, it doesn't exist, right? So here I'm going to put in the name of the thread. So this is thread 1. So let's call it 1. And this will be thread 2, right? Thread 1 and thread 2. So it's actually going to say, when I go thread 1, thread 2, it's going to go here, thread 1, count 1, thread 2, count 1, or whatever it's going to be, right? Let me update GitHub for you guys just to see that, because that would be bad if you can't keep up, right? So we go to team, commit, and we're going to update added custom thread class. And we'll add both those two things in there and commit and push. So you guys should have all that up in GitHub in the background. Okay, so if you want to check out and see what I did, instead of looking up here, you can always go up there from a time perspective. You can do that. Okay, let's run this thing and see what happens, right? So we're going to run our main program. Nothing's changed in my main program. Just I have two threads, plus I have my main thread, right? So let's check this out. So I go main count thread 2, start before thread 1, then thread 1, then thread 2, then thread 1, then main count 1, and then thread 1, and then thread 2, count 2, count 3. How come it's doing that? How come it's like interleaving exactly different things? This is what's happening. This is what happens with different threads. You can have multiple threads running at the same time. Like I said, each thread shares resources, memory, processor power, all that stuff from the main process, which is running. I haven't initialized another process. It's using the same application process right now. Every application has a process ID, right? This process that's running in this application has multiple threads now. So, you know, vis-a-vis multi-threaded, right? So again, not a very useful example, but to understand how you can run processes in the background, right? And they'll run in the foreground. Notice how in this particular example, we ran our main count first. Main count went to 0, and then thread 2 fired first, then thread 1, then thread 2, then thread 1. Even though I declared them in different order. Look, I declared thread 1 first to start, and then thread 2 to start. You know, I did those two things first, right? But, you know, how about if I want to stop a thread? You know, what can I do? Can I go like, you know, thread 1? I want to stop my thread. So, you know, when I'm starting off in this thing, if my, let's do this. I'll say in a catch, right? And I'll actually put it in my try catch, right? So make sure. I'll check this out. I'll say if, right, index, right, is greater than 5, right? How about that inside my little application here? If my index is greater than 5, then I want thread 1, right, to stop. Right? So I want to use interrupt. Right? So I want to interrupt thread 1. Okay. Now, luckily, I have it wrapped in a try catch, right? And it's going to give me this error that says thread interrupted. Right? Every time at line 5, at the 5th iteration of my main operation, whatever I've got here going, it's going to interrupt thread 1. But thread 2 should continue. Let's try this out. So plus, so we're running, and then main 0, main 1, main 2, main 3, main 4, main 5. Oh, there's my thread interrupted. And notice how it keeps going. The other stuff keeps going. My thread 1 should stop, right? Because I stopped thread 1. Right? And then, but yet, hold on, what's going on? How come it continues to count, even though I've interrupted it, right? My sleep was interrupted, right? 7, 8, 9, and everything continued. I tried to interrupt it, but I couldn't. Well, this is one of the problems when we create a thread that's part of a class. One thing is, a bad thing about extending a thread like this, right, is when we do this, you know, you can't extend any other classes. This is it. This is the class you're extending, right? It's better always to implement, you know, again, some kind of use composition to create some kind of object to use this thread, you know, or some other object to use here, or to implement an interface, right? So let's use this and make a new class that implements an interface that does the same thing. Okay, let's try this out. So we're going to go to, so source, new, Java project, or class, new class will be okay. And this class name is going to be myRunnable, right? And this time, the superclass is going to be the same. So Java lang object, but my interface is going to be different. I'm going to add a new interface. I'm going to click add. I'm going to click the runnable interface. So I can search for runnable up here. So I can go runnable, right? And I can search for the runnable interface and press OK. And if notice how it says Java lang runnable, right? Let's use also my constructors from the superclass. Let's do that, and any abstract methods. See what happens, right? And then press OK. Finish. I get this. This is good, right? I don't need this because my runnable. This is the empty constructor. I wouldn't need that, right? But we'll leave that here in a second. And let's do kind of the same thing. So I'm going to call this runnable. I'm going to ask for a name in my runnable, right? So we're going to add that in there. And make some copies. We're almost make it identical, in fact. And we'll look at the differences between one and the other in a second. Right? So we'll kind of copy and paste a lot of the same things, right? And we'll kind of take this and we'll put it in here. What's the difference between running? Essentially, they're the same. The only difference is now we're implementing an interface, which means I can implement many interfaces, right? And have runnables that are inside my class. And I have this run method that's been inherited from the runnable. I've overridden the runnable interface, the runnable method, right? That comes with the runnable interface, which is a much better way of doing it instead of making your own thread, right? Okay, so let's do the same thing here. I'm just going to copy all this stuff. So I'm going to go through here. Now notice I don't need I don't have to use my superclass here because I'm not creating a, I'm not overriding the constructor. So there it is. So I'm going to do one of these, and I'm going to go to source. Well, we're going to format everything so it's back into normal thing. And sleep, I need the thread now because it's not, because my runnable isn't a thread. I need to use thread.sleep, right? Because that's how it'll work, right? So I need to use thread.sleep. Otherwise, I won't be able to run the sleep function. So all this is good. And instead of thread here, we'll call this runnable, so we can differentiate between one and the other, right? Okay, so notice how we're just changing a few things around. Everything else is identical between one and the other. So we have a runnable, and we also have a thread. Okay, cool. Let's go back to my program.main or main program here, and let's do a couple things. Let's kill this interrupt for a second. We'll kill the interrupt, and instead of the thread 1 and thread 2 being of type my thread, we'll make it of type my runnable, right? So we'll say change this to my runnable, and we'll change this also as well. So we'll kind of copy and paste, make some changes here, and there we go. We'll take the same ideas, and notice how I have a problem now. I can't do the start method, right, on my runnable because my runnable isn't a thread. My runnable is a runnable, and it doesn't have a start method. It has a run method. So how do we overcome that? Well, we can make it so that we're going to create a new thread object. That's the way to do that. By the way, you can do an anonymous thread object as well, where I'm going to call the thread, which is equal to new thread. I'm going to pass in my runnable, which is my runnable 1, which is my thread 1. Right? Now I can start this thread start, right? As opposed to thread 1.start. And let's just for the simplicity's sake, notice how we have thread 1, thread 2. Let's change this to my runnable 1, my runnable 2. Just so we can differentiate my runnable 1 and my runnable 2. Mess this up a little bit for you guys. And of course, this will be my runnable 1, my runnable 1. And you know what? We're going to do another count. So this will be thread 1 for a second, and we'll make this thread 2. It's the same kind of idea here. Thread 2, and with my runnable 2. Okay, so I've got my runnable, right? But I'm passing in instance of instance of my runnable 1, my runnable 2 to thread 1 and thread 2. And let's see if there's any difference at all in what happens. In fact, it should be known. Just a different way of doing it. So, runnable 1, runnable 2, right? It kind of comes down here like this. And here's my main count 1, main count 2, all the same. But take a look at the way it's running. It's a little more ordered, no? Let's run that again. So run it. So 0, 0, 0, 0. Oh, 1, 1. And how come it runs differently every time? Anybody? What is it competing for here? I said it already a couple of times. Resources, right? CPU resources is competing with the operating system for different things, right? And remember, my operating system, I'm running a lot of stuff in the background. There's another process running in the background that's sharing resources with this process. Which process am I talking about? Actually, there's 2 processes that are running here. I got my Eclipse process that's running, and now I'm running a process with that's kicking off from this process, which is this little program that I'm running. That's another process altogether, right? And this other process that I'm running that's kicked off from the Eclipse process is running inside of operating system my UI, my Mac OS X process, right? There's many processes that are running that are spawned from different processes that are all competing for resources on my system. And you don't know from that perspective which of the threads of my process is going to run at which time, because none of them have more higher priority than any other one. Yes.
You said the processes compete for the resources. Okay, isn't it the thread competing for the resources?
The thread is competing for resources in the process.
Like
Each process is like a container, right? It contains all the programming logic, right, for each of the threads, right? Each thread is competing for memory and fighting for control of the main process.
Right, so a specific amount, like allocation doesn't take place. So, for example, once a process is created, a specific amount of memory is allocated for that process. Is it how it works, or is it dynamically changed all the time?
It dynamically changes based on what the resources are for the system. That's why it's crazy. That's why it's hard to. That's why, you know, making multi-threaded applications like this is so complex, right? I'm showing you where each of the processes are running. Can you really? Here's another question for you guys. Can you really depend on when these things will fire right now? No, right? Here's one more trick, right? Do you think that this for loop here, this run, is atomic? Okay, what does atomic mean? It means that it won't be interrupted, that this is running every time. Remember? It can't be, because if this is atomic, right, it goes in and it goes out, right? So let's say, for example, this little task that I run, we're going to call this task 1. And I'm going to you know, take this task and make it a method of my runnable, right? Let's do this. So right click, right? And I'm going to go to source, right? Is it source or maybe refactor? Refactor, and I'm going to extract method. Okay, so here's my method I'm going to extract, and I'm going to call this task 1. Task 1, right? And we'll click finish. Press OK. Yeah, okay, whatever. Who cares? Task 1, right? So there's task 1. And task 1 is a private method that's going to fire within my process. So this is my process, my run process. Task 1 is going to fire. Is task 1, right, atomic? Which means that it has to run and complete before any other task can run. In this particular case, the answer is no. You might think it is. And if you're only running one thread, right, you're good to go. But because we're running multiple threads, it's not atomic, right? It means that it can be interrupted. I can have other tasks running, right? Because each of these tasks, this in a runnable object, is running at different times. Look, they're running all different times. So how do I get them to run, as an example, right, all together? And there's a word for that, I believe, which is, if the keyword is synchronized, let me see if I can run this in. So synchronize. So if I go synchronize like this, I don't know if I put it in my task, if I remember the keyword synchronize, or if I put it before into my actual my for loop. But there is a way I can synchronize my object. How do I do that? So let's take a look at the PowerPoint really quickly. We talked about. I'm not going to talk about states. That's beyond our kind of scope for this one. One thing we did talk about is thread scheduling, which is what we're going to get into with the executor service, which we haven't run yet, right? But notice how in my I'm implementing runnable just like I am in the book, right? We're going to have to finish this later on. So I've got my task here, right? Which is doing some stuff, which is this is my public constructor that's running, right? This print task in this particular case, right? And notice how also I have this run, this void run, which is going to have, you know, the same idea, the sleep time, and it's going to, you know, kind of run this process. This is the runnable. Here, I can also have a scheduler that we call an executor service that I can create that creates a thread pool, right? And what I can do with the executor service is I can execute one of the tasks, right, based on, instead of using the thread start, I can use the executor service to do the same thing. So let's try this out, where I can do some synchronization, right? So how do I do that? I got to go back to my program, and in my main, where I have my this threads. Look at all these extra things we have here: the threads and this thread start. All this. I don't need any of that stuff. And instead, I can do something called an executor service, right? And I'll call it executor, is equal to, and before I do that, I should probably install it, right? So I import the executor service, is equal to executor dot And now there's different things. Sorry, let's go back here to executor. Executor service dot. Executors. Sorry, executors. That'll be okay. Dot, and then I can run for a new new thread pool. So if I go new, let's do instead of a cast thread pool, let's do a new fixed thread pool, right? With only I only want three threads running at the same time, maximum, right? There's my new thread pool, and now what I can do is I can use my executor. Executor. This is a scheduler. That's what this is. I can schedule each of my threads. Executor dot, execute, and I can put in my runnable, and it takes my runnable 1 or my runnable 2, right? Let's do this like this. So I can add 2 of my threads in there, and here's my runnable 2, right? Where I can run my thread this way. Let's see what happens here. So an executor service is a scheduler, right? And I've created a new fixed thread pool. I'm having a thread pool. Remember these threads? These are threads, components of my process that I create, and all I'm going to do is reuse them. I can only have 3 threads maximum in this thread pool. I'm creating a fixed thread pool of 3 possible threads. I go to my thread pool, take a thread, I use it for my runnable, and then when I use my runnable 2, I take another thread from the thread pool and I use that one. Then there's only 3 threads. That means I only have 1 more I can run concurrently, right? So I can control what's going on here. So press play and run it. And now, if you notice, it runs a little bit more cleanly, right? But same thing. Thanks. So that's it for now. Let's continue later on when we get back. And I'll finish it off with the synchronize keyword, how to synchronize processes so that they all have priority.